Hello everyone, this is LeetCode 235, lowest common ancestor of a binary search tree. Not sure how this is a medium problem. I've had easy problems that are harder than this one, but basically we're given a binary search tree and we have to find the lowest common ancestor node of two given nodes, and the lowest common ancestor is defined between two nodes P and Q as the lowest node in the tree that has P and Q as descendants. And a node can be a descendant of itself. So basically, this example, we have nodes 2 and 8. They both descend from 6, so 6 is the lowest common ancestor. Here we have 2 and 4. The lowest common ancestor is not 6, but 2, because 4 descends from 2, and 2 descends from itself, right? Because a node can descend from itself, in cases like this, you actually wouldn't return 6, but you'd return 2, since the node descends from itself. So the way to handle this problem is, well, we know this is a binary search tree, right? So we can check, we're going to start at the root node. And we can check, okay, is P and Q, if they're both less than the current node, we can just move to the left subtree. If P and Q are both greater than the current node, we can move to the right subtree. Now, if P and Q are not both less than the current node or not both greater than the current node, that either means that P is less than the current node and Q is greater than the current node, or that means that P might be the current node and Q might be greater than the current node, in which case, or that might mean P is the current node and Q is less than the current node. In which case we would just return the node that we're on. Okay? So yeah, the way we handle this, basically, we need to check, is P and Q less than the current node, or are they greater than the current node? If neither of those are true, we're just going to return the current node, because we know at that point it's just the lowest common ancestor, okay? So we're going to say, we can just set the node, we're going to create a variable node and set that to the root. And we're going to say, while node, if P is greater than the value of the node and Q is also greater than the value of the node, then we're going to move to the right subtree. So we're going to say node is equal to node.right. Now, if we have a case where P is less than the node and Q is less than the value of, if the value of P and the value of Q are both less than the current node, then we're going to move to the left subtree. So we're going to say node is equal to node.left. Else we're just going to return node. That should work. Okay. Now you can be like a little bit like more succinct if you want, and just like call this function on itself. We're gonna say if P is less than the root and Q is less than the root, then we can say return the lowest common ancestor. In this case, we'd move to the left. I'm just copying and pasting. I'm too lazy to write it again. So if P is greater than the root and Q is greater than the root that we're on, then we would move to the right subtree. If neither of those are true, we're just going to return the root, because at that point we're at the node that's going to be the lowest common ancestor. What did I write? Did I write it wrong? Return lowest common ancestor. Oh, sorry. I forgot to pass in P and Q. You obviously want to pass those in, because if you're calling this function on itself, P and Q aren't going to change, and they're both input parameters. My bad. But yeah, this is like a shorter way to write it, I guess. It's like more succinct. Either solution really works, doesn't matter. But yeah, I hope this I hope this helped you. Again, I don't really think this is a medium problem. There are definitely a lot of easy problems that are way harder than this. Um, but yeah, you just need to utilize and recognize that the fact that this is a binary search, recognize that this is a binary search tree, right? I mean, it tells you, but like, recognize that this problem being a binary search tree helps you, right? In your approach, right? As long as you recognize, hey, I'm gonna use this by the fact that this tree is a binary search tree, I'm gonna use that to my advantage. When you recognize that you can use that to your advantage, it makes this problem easier. So yeah, I hope this helped you, and I'll see you in the next one.